Hi friends, in this section we are going to deal with the Laurent series. Earlier in the previous videos we have seen the definition of the Taylor series and the Laurent series. Here we are going to see the example of Laurent series. So we have given the function fz and we have to find all possible Laurent series about its singular point. So fz is given in the numerator, that is 7z square plus 9z minus 18, and upon denominator, that is z cube minus 9z. So to get the singular point, what we do, we just put it denominator equals to 0, that is z cube minus 9z equals to 0. So in this way we have taken z common, it is z square minus 9 is equals to 0. For we have three factors, z plus 3, z minus 3 is equals to 0. Thus we have three singular points of fz, that is z is equals to 0, plus 3 and minus 3. Now about these 3 points we have to bifurcate this fz. So denominator is z plus 3, z minus 3. Using partial fraction, that we write here a by z plus b by z plus 3 plus c by z minus 3. So using by partial fraction, you are advised to do this. So thus we get 2 by z plus 1 by z plus 3 plus 4 by z minus 3. So in the coordinate system, in the coordinate complex plane, the value of z are 0, 3 and minus 3. So these 3 points are the singular points, and we have to find the Laurent series about this 3 singular point. It means we are going to deal with these 3 singular points and 3 different Laurent series expansion we required. So one by one we will deal with all 3 points. Here we start with the point z is equals to 0. For this point we have 2 domain, where mod z is less than 3 and greater than 0, and other one is mod z is greater than 3. So this is the first domain. By considering z is equals to 0 as a singular point, let us see the domain. So this is the domain for the first picture we have seen, and the second one is that we define the rest part of the complex plane, which is outside from the mod z is equals to 3. Now we consider the A. Here mod z is less than 3, that we can write mod of z by 3 is less than 1. It means our series should be in the form of z by 3. So fz, that we have 2 by z plus 1 by z plus 3 plus 4 by z minus 3. So we will deal with the last 2 term, that is we have taken the 3 common, that is 1 upon 1 plus z by 3 and minus 4 by 3 to 1 minus z by 3. When we expand it, when the denominator term goes in the numerator term, so it is 1 plus z by 3 power minus 1 and 1 minus z by 3 power minus 1. So that we can write in the summation form. Here you can stop as a Laurent series, or you can merge with these two summation part. So the first Laurent series about the z is equals to 0 in the domain mod z less than 3 greater than 0 is 2 by z plus summation minus 1 to the power n minus 4 z to the power n upon 3 to the power n plus 1. Now we consider the second domain, which is the exterior part of the circle, that is mod z is greater than 3. In this case, 3 mod of 3 by z is less than 1. So by you can compare later on these two series. So in this case again fz is the same, 2 by z plus 1 by z plus 3 plus 4 by z minus 3. Since we required the Laurent series in the form of 3 by z, so here in the second and third term we have taken z common. So it is 2 by z plus 1 by z into 1 plus 3 by z plus 4 by z into 1 minus 3 by z. Again this denominator term we will expand by taking the power minus 1, and it is going to be in the form of summation. So you should remember this summation form, how we write it. It is 2 by z plus 1 by z summation minus 1 to the power n 3 by z power n, and the last term is 4 by z summation 3 by z power n, where n varies from 0 to infinity. Again we have taken the common term summation form. So in this way we got here two Laurent series about the singular point z is equals to 0. So the 3 and minus 3 both covered in the first and second part. Now come to the next part. Suppose we have considered here the singular point z is equals to 3. So it has number of domain or region where we have to expand the Laurent series. The first one is mod of z minus 3, which is greater than 0 and less than 3. This will cover the circle, and here you can see the minus 3 is outside the domain. So this is the A part. Second region we have where z minus 3, which is greater than 3 but it is less than 6. So this part we have the B part. About this also we can have the Laurent series expansion. And the third one is mod of z minus 3, which is greater than 6. This is the rest of the complex plane that we define. So when we pick this three type of domain, so Laurent series expansion will be different accordingly. So one by one region we will select here. The first one is z minus 3 is less than, mod of z minus 3 is less than 3 greater than 0. So how we can write it? Z minus 3 by 3 is less than 1. If z minus 3 upon 3 is less than 1, then naturally the mod of z minus 3 by 6 will also less than 1. Why we do this? That we see in the series. Now 2 by z plus 1 by z plus 3 plus 4 by z minus 3 can be written as 2 by z we can write 2 by z minus 3 plus 3, and 1 by z plus 3 we can write 1 by z minus 3 plus 6. And the third term we keep it because it is about the z is equals to 3, so it will remain in the form of z minus 3. Now in the first part we take 3 common, so it makes 1 plus z minus 3 by 3. In the second part we take 6 common, so it is 1 plus z minus 3 by 6. So ultimately our series is going to be in the form of z minus 3 because we are taking the series about the point z is equals to 3. That we have done earlier. Again it is in the summation form you can write. So it is 2 by 3 summation minus 1 to the power n z minus 3 upon 3 power n plus 1 by 6, again summation minus 1 to the power n z minus 3 by 6 power n, and the last term is plus 4 upon z minus 3. One thing we should keep in our mind, if we are talking about the Laurent series or Taylor series about the point z is equals to 3, so our series is going to be in the form of z minus 3. Now come to the next domain where z minus 3, mod of z minus 3 is greater than 3 and less than 6. So in this case how we can write? 3 upon z minus 3 we can write less than 1, Also 6 upon z minus 3, sorry, it is z minus 3 upon 6 is less than 1. So we have the two conditions now. In one case it is 3 upon z minus 3, and second case it is z minus 3 upon 6. So our series fz, function fz, we can write 2 by z again, it is 2 upon z minus 3 plus 3, and 1 upon z plus 3. Now this time we can again write z minus 3 plus 6. The last term will remain same, 4 upon z minus 3, because it is already in the form of z minus 3. In the first, what we can do, we have taken here z minus 3 common, so we can write 1 plus 3 upon z minus 3. And in the second, again we take 6 common, so it is 1 upon 1 plus z minus 3 by 6. We can write it in the summation form, and this is the required Laurent series expansion about the second domain. In the second domain, about the point z is equal to 3. Similarly, we will have the third domain, where we can, in the third domain is what, z minus 3 greater than 6. So it is 6 upon mod of 6 upon z minus 3 is less than 1. Our series should be in the form of z minus 3. Again fz, using partial fraction, we have 2 by z, again we can write in the same way, 1 upon z plus 3 also in the same way. But when we take the common, that is 1 upon z minus 3, 2 upon 1 plus 3 upon z minus 3, and b part also we can take 1 upon z minus 3 common. Since 6 upon z minus 3 is less than 1, so naturally 3 upon z minus 3 is also less than 1. As usual, as previously we have discussed, we write it in the summation form, and this is the required Laurent series expansion about the point z is equal to 3 in the third domain. Come to the next. Okay, yeah, that we have written here, z minus 3 is greater than 3, so 3 by z minus 3 is less than 1. Come to the next, the case 3. It is about z is equal to minus 3. So very quick, we have again z plus 3 which is greater than 0 and less than 3. Second domain we have z plus 3 which is greater than 3 and less than 6, and the C, that is the last, z plus 3, mod of z plus 3, which is greater than 6. So in this way, again here we have 3 domain. In the first domain we covered here 0 and minus 3. In the second domain we covered the plus 3, minus 3, plus 3 and 0, and the last one is outside all the points. So similarly, A is what, mod of z plus 3 less than 3, so it is mod of z plus 3 upon 3 less than 1. If it is less than 1, then z plus 3 upon 6 is also less than 1. So in that case, what we do now, the second term we keep it in the same way, because we are having the Laurent series expansion about the z minus 3. So all the terms should be in the form of z plus 3. Here we have taken minus 3 common, so it is 1 upon 1 minus z plus 3 by 3, and in the second it will remain same, 1 upon z plus 3 minus 4 by 6. Here we have taken 6 common in the denominator, so it is 1 upon 1 minus z plus 3 by 6. Again we write this in the summation form, and this is the what Laurent series expansion. Similarly, third one is the strip, mod of z plus 3 which is greater than 3 less than 6. So we will have these two conditions, 3 upon z plus 3 is less than 1 and z plus 3 upon 6 is also less than 1. So it is 2 upon z plus 1 upon z plus 3 plus 4 upon z minus 3. Again we deal with the first and third term, second we will keep as it is. And now you can judge, here we have taken the common z plus 3 and here minus 6 we have taken common. And this is the required Laurent series expansion. So 3 upon z plus 3 and the second term is plus 3 upon 6. Very quick, we will see the third term, that is z plus mod of z plus 3 is greater than 6. So 6 upon z plus 3 less than 1, as well as 3 upon z plus 3 also less than 1. So in this way, in the first term we have taken z plus 3 common. Also in the third term we have taken z plus 3 common. Minus we have taken sign. So both series will be in this way. The same concept we have. So thank you for watching this video. I hope it make clear about the Laurent series expansion, about the different point in the one example. So if you feel good, so like it, share it and subscribe our channel for more update. Very soon we will come with the more different topic related to the complex analysis and complex number. Thank you for watching this video.